Hello, everyone, and welcome to the second event of the second fall series organized by FunctionalFest. We are a group of Italian developers in love in functional programming, and we are starting to enjoy to organize online events around functional programming, just to bring together all the communities which gravitate around functional programming, both in Italy and abroad. You can find all of our previous events on our YouTube channel. And if you want to keep in touch with us, just to follow what we are going to do in the future, you can follow us on Twitter. Our account is @FunctionalFest. You can subscribe to our channel on YouTube, or you can just check our website, www.functionalfest.it. Before introducing the speaker of tonight, I'd like to thank DoubleLoop for their technical support and the infrastructure they provide. And tonight, it's our pleasure to host Marco Sampellegrini. He is a software consultant. He worked with Haskell and Elm for the past few years, settling on TypeScript now as the more pragmatic choice for new projects. Marco recently published a book, his first book, called The Simple Haskell Handbook, which is available on Limpub. Go check it out. But tonight is not going to speak about Haskell. Is going to present his talk about HTML over the wire meets functional programming. And remember, if you have any question, just ask it on the YouTube chat and we will relate it to Marco at the end of the talk. So Marco, the stage is yours. Good luck.
Yeah, thanks for having me. So I'm Marco, and I'm going to be talking about HTML over the wire, which is a new approach at building web applications. And in particular, I'm going to focus on how it applies to statically typed functional programming. And we're going to be looking at some of my experiments with TypeScript. With that being said, it's not going to be a talk full of, we're not going to be talking about types for the entire talk. It's going to be fairly lightweight. And so let's get started. I'm Marco. I'm a software developer from Italy. I work with technologies such as Haskell, Elm, PureScript, and most recently TypeScript, which I'm enjoying a lot. And as mentioned, I recently published a book called The Simple Haskell Handbook, which is a very practical book where we get to build a continuous integration server from scratch. So if you're interested in Haskell and you're looking for a hands-on project to work on, go check it out. So the core thesis of this talk is that building web applications is hard. And it's hard for a number of reasons. So building a modern web application means having to deal with complex tooling. So stuff like Webpack and Babel and transpilers and all that stuff, which is very complex to deal with. But it also means really building two applications. So maintaining two code bases, one for the backend and one for the front end, and having to take care of both of them and having to deploy them and somehow keep them in sync. And also, like, building a web application is hard because you have to worry about having these two applications, the backend and the front end, talk to one another. And so at some point you have to worry about data serialization and how to somehow turn your data model on the backend so that the front end is able to understand it. And so even if you use a type-safe language such as Haskell or Rust, eventually you're going to have to take your data model and turn it into JSON. And so in all likelihood, you're going to expose an HTTP API or something like that, and you're going to send some JSON to the client, which is going to be a single page app implemented in React or something like that. And so JSON is not a very expressive language. And so maybe the way you encode your types on the backend can be surprising when you try to read that data back on the front end. And so maybe your application compiles and everything sounds good on the back end, but the moment you send your data over, then your app explodes at the runtime. And there are solutions to this. Maybe you use GraphQL, or maybe you generate types for both the backend and the front end from a shared schema. Or maybe you use data transfer objects, but then you have to maintain a lot of boilerplate because you have the same type duplicated for your domain model and for the data that you send over the wire. And you have to be very careful with deriving instances. So for example, in Haskell or Rust, you can have the compiler derive the code for generating JSON serialization and deserialization. But as I mentioned, this can behave in a surprising way sometimes, just because JSON is not as expressive as we'd like it to be. And so when you think about it, why are we even sending all of these JSON data over the wire? Why are we sending all of these JSON data back and forth? And the reason, as we said, is because we are building two applications really, but maybe that's not the best way of going about it. I'm realizing I might be covering the slides. So I'd like to take a couple of minutes just going over how we used to build apps in the past and how we might be building them in the near future. And so in the 2000s, we would be building apps as a single code base. So the typical application was a spaghetti PHP app, and it was simple. It was very easy to deploy. You would just throw files on an FTP server, and obviously it was unmaintainable because of the lack of static typing. And the user experience for the end user wasn't great, because anytime you clicked on something, the page would refresh and the UX would be quite jarring. So we got to where we are today. We need to handle an app for the backend and an app for the front end, and these tend to be quite complex. It takes a lot of effort to maintain, but we've also seen, more and more, static typing getting more and more popular. So that's a good thing. And, working with a single page app means that the UX for the end user tends to be quite good, because now when you click on something, you don't get a full page refresh, and single page apps are snappy, responsive, and fast. And so that's what we like. And I wonder what the next 10 years are going to look like. I think we're gonna see the pendulum swing back to a single code base, and we'll get to a point where we get the best of both worlds. So we do keep the great UX of a single page app, but we'll also get back to a simpler model that takes less effort to maintain and deploy. And maybe that approach is HTML over the wire. So yeah, the goals, as I just said, we want to keep the best of both worlds. And one thing that is quite clear from the recent developments in web app development is that the Elm architecture is quite great, and it's a great pattern in building an application. And if you've never used Elm, I'm sure you've heard of Redux in the React ecosystem. Maybe you used it yourself. It's basically the same idea. And so the idea is that you have a little bit of state that drives the UI, and you have a pure function, which is usually called a view or a render function, that takes the state and turns it into HTML. And then you have an update function that takes a message or an event and the current state and returns the updated state so that the UI re-renders and everything works. And maybe the key to move to get to a simpler model is to just move this pattern to the server. So right now, all of this happens on the client. We have a client that handles the state of the app, and we write the code to update that state on the client, and the render function is on the client. But maybe there is a way to move this to the server. And so if we do this, if we let the server keep track of the state of the app, then we don't have to send data to the client anymore because the state is on the server. And so we can just send HTML over the wire. And so right now, when we build a web application, we are sending JSON back and forth over the wire because the client needs data to work. But if we take this approach, then we can just send the HTML over the wire. And so the client would just be a tiny piece of JavaScript that receives HTML updates from the server and it applies them to the DOM, to the page. And the first project that has explored this idea is Phoenix LiveView. Phoenix is a framework for the Elixir programming language. I'm sure most of you have heard of it. Elixir is a language that runs on the Erlang virtual machine. And so it's the perfect playground for this idea to work, to explore this idea. Because in Erlang, you can spawn literally millions of processes, and each process can have its own state. And so whenever a user connects to your web application, a new process is spawned, and the state for that user is kept on the server. And then there is a WebSocket connection where HTML updates are pushed back to the client. And this is great because just by making this shift, just by shifting the state from the client to the server, we have solved, all the problems that we outlined in the beginning. We no longer have to expose an HTTP API. We no longer have to worry about REST. There is no JSON serialization that can go wrong. We don't have to expose a GraphQL endpoint and all that. It really is a powerful abstraction. And there are other projects that are exploring these ideas as well. One is Laravel LiveWire in the PHP ecosystem, or you might have heard of Hotwire in the Rails ecosystem. And I think there is a lot to like in this approach. I think it's really compelling, but I didn't find anything that worked with a statically typed language. And so I started playing around with my own implementation in TypeScript. And initially it was just, a little bit of experimentation just to get familiar with this way of building apps and see for myself how it worked. But then it evolved in a fairly, I would say, interesting project that I would like to share with you. And so my project is called Riwi, and it's an HTML over-the-wire framework for TypeScript. And the core abstraction in Riwi is that of a component. And component is such an overloaded term nowadays that it doesn't even mean anything anymore. But you can kind of think of it as a React component. And so a component holds a little bit of state, and it can react to an action. So this would be an event or a message if you're coming from Elm. And so a component exposes three functions. The one function is mount, which is responsible for returning the initial state of the component. Then we have render that takes the initial state, the current state of the component and turns it into HTML. And then we have an update function that takes the current state and an action and it mutates the state depending on the action that was received. And so let's look at an example along with some code. So here I have, maybe I can show this again. Here I have a simple page. It's supposed to be a counter, but right now nothing works. So the code for this component is very simple. As I said, a component has a state and an action. So the state for a counter is just a number, and an action can either be, increment the counter or decrement it. And so we call the find component, and the mount function is very simple. We just initialize the count to 0. We're going to be implementing the update function in a second. And the render function, as we said, it just takes the current state and it returns some HTML. And so one thing to note here is that this is JSX. So it's the same thing that you would use in React, except that there's no React running here. All of this gets turned by the TypeScript compiler into function calls. And, and then it gets turned into a plain HTML string. So if we want to get this component to work, we need to do two things. We need to bind events to these two buttons, and we need to implement update. So I'm going to start by implementing update. So update takes the current state and the action that was triggered by the front end, so either increment or decrement. And we could just be using if statements here, but that wouldn't be the best way of going about it. And so TypeScript doesn't support exhaustive pattern matching by default, but there's this wonderful library called TS-pattern that implements exhaustive pattern matching in userland, which is super cool. And so I can match on action and say that when action is increment, I want to change the state so that we increase the count. Oops. And when it's decrement, I want to decrease the count. And so when I call exhaustive now, this will effectively work as a pattern match. And if I comment one of the cases of this pattern match, you can see that there's a type error here because I'm not handling all the variants of my type. So that's super cool. So we've implemented the update function. The other thing we have to do is bind events to these two buttons. And so to bind DOM events, Riwi exposes these R object, which is just an helper object that you're going to be using very often. So I just called it har. Could have had a more descriptive name, but R will do for now. And so you can see that you can bind to all sorts of DOM events. In this case, I want to bind to the click event. And you can see that the compiler is correctly inferring that I can, I will be triggering actions of type action from these click events. And so here I will trigger an increment action, and then let's just copy this tag and use decrement. And so now the page auto refreshes, and when I click on a button, it works as expected. So this is super cool because all that we're doing here is running on the server. So this might look like a component that you would write in a React-ish framework. But in fact, all of this is running on the server. And so if we take a look at the network tab, when I click on a button, you can see that a request is made to the backend. And if I look at the HTML, you can see that some HTML is being rendered by the backend. And there's a tiny bit of JavaScript on the front end that updates the DOM. So you can see that the patching of the DOM is very efficient. It doesn't trashes all the nodes on the page, but it updates only the node that has been changed. And so this is cool. We can bind to click events, but it would also be cool if we could bind to input fields. And so let's say I'm gonna add another property to my state, which is gonna be name of type string. And I'm gonna initialize it as my name, Marco. And so down here, I wanna have an input field of type text. And I want to somehow bind the name property from the state to this input field. And just to make sure it works, I'm gonna say hi state name down here. And so you can see that currently the input field is blank, but the state has the correct value inside of it. And so the way we bind a property from the state to an input field is again by using the R object. And this time we use the register function. And so again, the compiler is inferring correctly that we can only use properties from the state. And so I'm going to be using name. And now just by doing this, I get two-way data binding on this input field. And so if I change the value of this input field, the HTML will re-render automatically as well, which is kind of insane. It didn't work that time. Okay. Cool. So again, the most mind-blowing thing about this for me is that everything is running server side. And if you want to think about this as old school PHP, like the fact that you can write everything in a single file if you want, to me is kind of crazy, and I love it. So if you want to think about it as a PHP file, I'm fine with that. And so again, everything here is running server side, and I'm going to be showing you some examples where this is more apparent. But what it means is that if you want to, run a database query in your mount function, you can just do it. And there is no API call. You don't have to expose an endpoint on your backend or anything like that. And so let's look at a couple of other examples. This is just a simple form. It's a demo form that I wrote just to showcase that you can bind to all sorts of input fields. So you can bind to selects, to checkboxes, to radio buttons. And what you see here on the right is the state of the component as it's being seen by the server. So if I update this text area, the state updates. If I click on this radio button, the state updates. And this is great because it means when I get to save this form, when I submit this form, I don't have to collect all of the data as I would have to do in a single page app and then send it to the backend. I can just use the state that I already have available on the backend and just, store it on the backend, store it in the database or whatever. Now let's look at another example. This one is pretty cool, I think. So here I can look up words. This is an autocomplete field. It's nothing groundbreaking, but again, it is working entirely on the server. All of this is rendered entirely on the server, and there is no client-side JavaScript needed to write something like this. And so what you need to do to implement something like this is very simple. So we have our state again, and we have our query, which is the the value of this input field. Then we have an array of matches, which are the words that match a particular query. And then we have a result, which is supposedly, the definition of a particular word when you click on it, but this is not implemented. And so the action for this component is either suggest, so update the current match, the current list of matches for this component, or you can search for a specific word. So when I click on one of these words, I want to search for its definition. And so the mount function is very simple. And the update function is the interesting bit. So when I get the suggest action, I first check that the query is not empty. And if it's empty, then I just, mutate the state to return a list of an empty list of matches. But if I do have a query, then I can just call grep on a file full of words, and I just, splice in my query, and this works just fine. And I can do this because this code is running on the server. So if this were a React application, what I would have had to do instead, is call fetch and implement an endpoint on my server, and return the data as JSON, read it back on the client. It's just a ton of work. And by moving the state to the server, all of that stuff is redundant. I can just do the thing that I want to do here and be done with it. And so the moment I update the state with the updated matches, then render is called again, and it just goes through the matches, and each word gets its own div. And when I click on one of these results, the search for word action gets triggered. And so a very simple component, but it shows how powerful this approach is, because you always have the power of the server at your fingertips. And so one last example. This is the one that blows my mind the most. And so, as we said in the beginning, single page apps are great because the user experience for the end user is good. They are responsive, they are fast, but most of all, they don't trash the state of the page when you navigate to another page. And so this is a demo page. It shows a list of artists over here, and these are two separate components. I have a sidebar component and a detail component. And when I click on one of these artists, the component on the right updates as well. But you should notice that the URL updates as well, and the title of the page also updates. And so when I click on another artist, I don't get a full page refresh like I would get in a fully server rendered app, but at the same time, I get the same experience that I would get in a single page application. And so if I click on the back button and the forward button, it still works as expected. And the scroll position of this sidebar is maintained. So this effectively works as a single page app, except that it's entirely server driven, and I didn't have to write a single line of JavaScript code on the client to make this work. And so when I navigate to a new page, when I click on this link, it will navigate to a new route. And again, this will not trigger a full page refresh. And the navigation component that I have here is able to update itself, which is great because it means you can persist components across page navigations. So you can imagine if you had an audio player here, you wouldn't have to trash its state when you go back and forth between a page and another one. And so, yeah, something like a video player or an audio player will keep playing even if you're transitioning to a new page. And so one last thing I want to show you here, I have, a form here is nothing groundbreaking. And here I have a lineup for a concert or whatever. And I can add an artist. And this is a model, which is, the level of interactivity that you get in this model is quite, is similar to what you would get in a single page app. And so I can scroll these results back and forth. I can filter these results. And again, none of this requires any client-side code. This is entirely server-driven. And so when I click on a result, the model closes and the form updates. So I want to show you the code for this because it's, you know, it's simple and straightforward as you would expect. So obviously it's a little more involved than what we've seen so far. But again, it boils down to defining a state type and an action type. And so the state is going to have a model state embedded in it. And the model, as we've seen, is going to have a search query, is going to have the current page, it's going to have a list of results. And, you know, the model is either opened or closed. And then the action type is very straightforward as well. So I can either move to the next page in the model. I can toggle the model visibility. When I select an artist, you know, the data type is fully, you know, descriptive. It's as simple as it can be. And yeah, the update function is super straightforward as well. Toggling the model state, it just means changing the open property. When I click on next, I just bump the page property and then I call paginate again. So this is very straightforward, and you can see how I can get quite complex, you know, user experience just by writing very simple code. So this is pretty much all the demos I had. Yeah, the gist of it is that we can get the same user experience as a single page app. And so is this a better way to build applications? If I had to list the benefits of this approach, is that we can go back to, you know, effectively working on a monolith, which for all intents and purposes, it's easier than working on two or even, you know, often even more than two code bases. And so having a single code base to me is great. And this approach is simple and maintainable. It kind of looks like the old school way of developing an app, where you would just throw PHP on a file and it would work, except now we have types and it's much more maintainable. And the only abstraction you have to worry about is that of the component. Just by sticking to the component abstraction, you can build pretty interesting things. And the last point is that we were able to get the same user experience of a modern single page app, except I didn't have to write a single line of JavaScript client side. This is all HTML that gets sent by the server to the client. And the client is smart enough to know what to do when it receives a response from the server. And so I'm going to leave you with a quote from, what's happening? Oh, God. I'm going to leave you with a quote by Chris McCord, which is the author of Phoenix LiveView. And he says, I believe we've hit on some new ideas that will change the way we think about building applications in much the same way Rails did for CRUD apps. And obviously he's referring to Phoenix LiveView. And the thing I've just shown you is nowhere near the the level of maturity that Phoenix LiveView is at the moment. But I believe the statement applies to Riwi as well. And so if you want to check it out, there is a documentation site. I wrote some documentation to get started and to play around with the examples that I've shown you. There's also a repo on GitHub. If you want to talk more about this, I'm on Twitter, or you can find my other contacts on my website. And so this is all I had to share. If you have any questions, please feel free to ask.
Okay, Marco, thanks for the nice talk. We actually, let's wait a couple of minutes if anyone has any questions in the YouTube chat. And I also remember to our audience to drop a line with a question for the speaker if you have any. In the meantime, I do have a question. I have a bunch of questions actually. The approach is very interesting. One of the question is, I mean, it regards the language and how the application, how you think the application should be written. What do you think about the isomorphic single-page applications, for instance, and what do you think about the difference with your approach? And I mean, is this also like based on code sharing between the server and the client? Many questions, but I think they are all related.
So the premise of the isomorphic approach is that you should be able, you write your client-side application in React, and then somehow on the server you have a node application that is able to mount your React code and server render it so that you don't get a blank page the first time you load the website. And this works in theory, and with newer frameworks such as Next.js, this is becoming more and more attainable. And the React team has also announced React server components, which I believe should improve the situation even further. But it doesn't change the fact that you're still building effectively a client-side application. And so you still need a backend that talks to the database, and it exposes an endpoint in some way, shape, or form that will communicate with the client-side app. And so the difference with that, with this HTML over the wire approach, is that you don't think about writing client-side code at all. And so your application is fully server rendered, and there is no code sharing between the server and the client, because the client is just a dumb JavaScript library, which is very thin, and it just knows how to talk to the backend and how to patch the DOM of the page when it receives some HTML back from the server. So on the surface, they might look like very similar approaches, but when you start looking a bit deeper, the ramifications of moving the rendering back to the server and moving the responsibility for handling the state back to the server the ramifications are quite big, in the sense that you no longer have to worry about exposing an HTTP API anymore, because the client wouldn't have to talk to it. It's all server driven.
Yeah, okay. In this regard, do you think this approach can lead to let me call it an entanglement between the presentation layer, which basically is HTML, and the, let's call it the backend
definitely
side? Okay.
So when I said that this is basically old school PHP, I meant exactly that. So this is from an engineering perspective, this is the worst thing you could possibly do. Like, this crams together all concerns in a single abstraction. But I want to offer a couple of counterpoints to this. So when JSX was first introduced, and JSX, is the HTML-like language that was first introduced by React. When this, was released, I remember people going crazy because now you were modeling your JavaScript layer with your presentation layer, and this was supposedly a bad idea. Except, a few years later, now everyone is on board with it, and it's not a big deal. And one more, a more recent counterpoint that I can provide, which hasn't proven to be, it hasn't made its case yet, but I think it will in the coming months and the coming years, is that of Tailwind CSS. And so the idea that you can use utility classes to style your presentation instead of maintaining a separate style sheet. So if you've never heard of Tailwind, it's the idea that, for example, if I wanted to add a margin to this div, instead of adding a new class to my style sheet, I can just say MT4. And so this is a CSS utility that says add a margin top to this div of 4 units, which typically is, it's going to be 16 pixels or something like that. And so you get to the point where, let me show you. I hope that's the website. Yeah, you get to the point where you have this crazy code, like your HTML is completely riddled with stuff which doesn't belong there. So this is all CSS stuff that in principle shouldn't be in your HTML. But I'm gonna bet that, in the coming months and in the coming years, this is gonna become more and more popular because it's so much easier to have all of your code in a single place. And so that's what I really like about my thing as well, is that if you want, you can have everything in a single place. So the state of your app in a single place, the way you update that state is in the same place. The HTML for rendering that state is in the same place. And if you want, you can also add the CSS in there. And so we would get to the ultimate nightmare of the engineer that wants to do things right, and that would find this disgusting. But in practice, when you work on a real world application, it turns out that having a single abstraction that allows you to work on all concerns from a single place, I think it's ultimately the right way to go. And I could be wrong, obviously, this is subjective.
Okay, thanks for the answer. Very nice. I think we have another question, which, concern about the complexity. This is probably, regards Riwi too. So you cited the Elm architecture in the beginning of your talk, I think. So that's terrific, actually. It's very, very sleek. But on the other hand, it brings some complexity when the application grows and becomes very large in terms of number of messages which update the model. So did you identify any strategies or patterns, probably in Riwi, to, handle this?
Yeah, let me say something first, which I didn't mention. So it's spelled Riwi, and the way I called it Riwi is because I wanted to play on the word wire. So it's kind of like Dino and Node and the way they are related. I thought it was funny. So yeah, the Elm architecture tends to cause problems when you have a ton of messages, because ultimately you have to cram all of your messages and all of your state in a single type, which for big apps can be problematic. But I don't think this applies to Riwi, because you can split your state and your actions or your messages into multiple components. So here you can see this function render child, which is the way you render another component within a component. So it's the way you nest components with one another. And so, for example, the navbar component here has its own state and its own actions. And so it's a very simple component. It doesn't have any state at all. And the only action that it handles is the page updated action. So when you navigate from a page to another page, this page updated action will be triggered. And all that happens is that the component will be re-rendered. And so, yeah, it can definitely be an issue, but if I go back to the artist page down here, you can see that this component is fairly simple, and all it's doing is rendering 3 components, all with their own state and all with their own supporting their own actions. So each of these components has its own mount function, its update function, and its render function. And this is very different from Elm. It's more in line with how React works. And I agree with you that in Elm, if you have a ton of messages, it can get quite complex.
Okay, thanks. Yeah, there are people in the chat stating that they want to start using Riwi.
That's great.
You got them. I think we have some other minutes, so if anyone wants to ask a question to the speaker, you're more than welcome to do. In the meantime, I think we have another question from us, which is, well, what about testing?
Well, I'm glad you asked. So, how can I show this? Let me see. There is some, where is it? I think it's here. So there are some facilities to test components right now. Obviously, it can be better, but what I have so far, I think is pretty good. And so the way you test a component is this. So counter is a very simple component. It's for all intents and purposes the same thing we've implemented here. And so if I wanted to test this component, I could just call make testable on it. And make testable is a function that allows me to initialize the component as if it were rendered on a particular page. So I can say the query parameters for this page are so-and-so, or the URL parameters are this, and it would mount the component as if it was rendered on that page. And then, it's just a matter of checking whether the state has a certain properties, or if the HTML wants rendered as certain, strings. And then you can either update the state directly and verify that the state has effectively changed, or you can call an action supported by the component. And so when you call an action, the state updates and you can do all your assertions. And, there are other methods that I'd like to support, but this is the basic yeah, I think you can get quite far just by using this API. It doesn't cover all cases, but this gives you a very fast way of testing your components. With that being said, I'm a big fan of integration testing. So I have a huge suite of tests for my playground project, which includes the examples that I've shown you. And so I tend to just write tons and tons of integration tests to make sure that my app is working the way I intended it to. But yeah, if you want to do unit testing, this is the way to go.
Okay, but you also add like backends tests in the integration suite?
Say again, what tests?
Like backend tests, like the tests. Do you also allow connection to the database in the integration suite, or that's just about
This talks to, like, remember that all of this is running server side. So this is running against an actual server. And so if you have a database query there, this would hit it. And that's why I like to do this kind of testing, because then you're able to verify end to end if your database is working properly and all that.
I see. Yeah, it's testing from the database up to the presentation layer. So
yep.
Yeah, end to end, true end to end. Okay, that's amazing. Okay, so I see no more questions from the audience. So let me thank you again for the amazing talk, and also let me remember to our audience that if you want to stay updated with upcoming talks, you can either go to our website www.functionalfest.com or follow us on Twitter. Our handle is FunctionalFest. And well, let's thank Mark again with a virtual round of applause. And see you next time.
Thanks for having me. It was a pleasure.